All right, 3D, right? All of them. Number one, classify each of the following variables as qualitative or quantitative. And if it is quantitative, discrete or continuous. Occupation. Qualitative, it's not a number, it's a description. Okay. Region of resident. Qualitative, weight. Quantitative, discrete or continuous. Technically, it's continuous, but the way we treat weight is discrete, right? We usually just round it to the nearest pound, or if you're a wrestler, maybe you go to a tenth of a pound, but we never report continuous weight. So that one's it's kind of tricky. What did the book say? Continuous. So technically weight is continuous because you can be any weight from 0 to whatever you get, anywhere in between. Okay, height. Quantitative, same thing, continuous. And number of automobiles owned. Quantitative, discrete. You don't get credit for half a vehicle, right? Either you own the title or you don't, right? If it doesn't run, you still own it. If it only has one tire, it's not going anywhere, but it's still one vehicle. So discrete. Okay, in March, the current population survey asked women how many children they have. And this is a little, oh, this isn't the one I was thinking of. Never mind. So is the number of children discrete or continuous? Discrete, right? Even my small little miniature children get counted as one. Okay. B, so draw the histogram. So when you draw a histogram, you get to pick your class intervals, but the book has done us a favor, and it will always list them in class intervals that we can use. So we're going to have 1, 2, 3, 4, 5. And you can do the boxes in two different ways. You could graph the first one here, or what did we do yesterday that made it a little bit easier to see? We put it in the middle. So instead of having an endpoint convention, we just center it on 1 and center it on 2 like that. Okay. Now we can do that in this case because we're doing every single discrete number. The continuous ones get a little bit more complicated, but that's not the problem here. All right. So number of children, 0, 1, 2, 3, 4, or 5. And we want to graph the histogram for high school graduates and for college degrees. Okay. So each one of these has a class interval of 1. That makes our life really easy. Why does having a class interval of 1 help? What's that? It makes the heights easier. If the widths are 1, how do we graph the heights? What do we need to do to them? Nothing. We just graph them, right? So I'll do the first one in blue, and the highest we go is 50. So 10, 20, 30, 40, 50. So we're going to go up to 30, and then let's make that a little bit bigger. Up to 30, and then up to 21. I guess that should be a little wider too. And then 28. So 28 and 13. Oh, wait. 10, 20, 13 would be here. And the last one, did I mess up? Oh, 0. No, I didn't. All right, and then we have a 4, and then we have an even smaller one. Okay, I'm going to graph the other one right over the top. So almost 50 and 19.4, 22.7, and then a bunch of small ones. Okay? What do you conclude? What do we get from this? Women with college degrees have what? Fewer children. Because children are discrete, they're countable. Okay? So, does college cause women to have fewer children? Maybe. Was this an experiment or an observation? Observation. Observations do not tell causation, they just tell association or correlation. So it might be the case that college causes women to have fewer kids, or maybe women who don't want many kids go to college more often than women who do. Okay?